Hello, everybody, again. Thank you very much to everyone that's followed the session so far today. We've come to our panel discussion now, and we have a handful of extremely talented individuals with us. So we have John Leach from AECOM, Michael Boyd from WSP, and Emily Scoones from Ramboll. Now, they'll introduce themselves slightly further in a moment. Well, let's start with that. John, do you want to go first and introduce yourself?
I can introduce myself, yeah, and I'll take you through this slide we have on the screen at the moment as well. So I lead AECOM Structural Engineering Technical Practice for Europe. I also chair the iStructEase Digital Workflows panel. So we've been talking about data in this context for many years, going back to when we were sort of first wrestling with BIM maybe 15 years ago. And when we talk about data-driven design, first question we're asked is what data and how do we use it? So on this slide, I've just sort of outlined the journey that we've been on in AECOM in recent years, trying to establish this step-by-step approach so people actually understand why getting the basics right is so important to achieve the more progressive and blue sky goals. So starting point on the left-hand side is really starting to automate aspects of the design process. You've seen examples of that today, really hinging around interoperability, linking analysis models with BIM documentation. Then having established those efficiencies, we're really trying to move beyond that. And in the design process, we're then creating lots of different design solutions that have been generated under common workflows and data conventions. So that gives us the opportunity to really interrogate and compare those designs like for like, giving us informed decision making. We have a whole raft of design options where we can look at cost, embodied carbon, and other parameters and start optimizing against those. So then we move on to saying, well, we've created these solutions in a standard way. We can start creating quality control digital libraries of common components. We start to layer the detail onto those, and that takes us into the design for manufacture piece, where we can collaborate more with fabricators and contractors. Again, there was some good discussions on that earlier. And once we've established those design for manufacture principles, we have model data integrity from the design stage right through to the construction stage. That opens up our engagement with things like digital twins, considering the sort of the in-service asset management, measurement of real performance of buildings, and starting to learn from that and use it in the future. Finally, then we say, okay, we've created those data sets. We're in a position to truly start to leverage the potential of AI, machine learning, generative design. That then informs the design automation really to the next level, and you would augment this whole cycle. So that's kind of my, I suppose, introduction to what we've been doing at AECOM and what the approach has been. But I'll stop talking now because I'm sure people want to talk and discuss.
John. No, thank you so much. No, that's excellent, and I'm sure people will have a lot of questions about that. So let's move on to the next slide, which is Emily. Please, you want to just introduce yourself and what you do at Ramboll?
Yeah, so I'm a senior computational design engineer at Ramboll, and I would say my journey has been very similar to John's in that I've sort of started out, creating apps which have automated workflows, due to creating, parametric constraint models which embed way more sort of pieces of information from various different parties to enable, ideas to be tested against those variables in order to check you're working within the many constraints that structural and building projects have. And this has evolved into now being part of a generative design team where we're actually looking at how we can use data to really drive design from a very early stage and take our learnings from much later in the design process and pull them in. And I guess the sort of key take-homes that I've found from this sort of journey is that all of these different things are different levels of how data is driving design, and more importantly, driving good design, we hope in the end, and how important it is to have data from all different sources in order to really get a holistic view and come up with the best solutions for the problem. And a huge part of that is kind of feedback loops, both in terms of multi-criteria optimization, but also what more can we learn from the end of projects and bring back into the beginning of projects in order to, drive better designs.
Fantastic. Thank you, Emily. Okay, and just quickly move on just for Michael's introduction. Michael, if you want to give us a few words about yourself and what you do at WSP.
Sure. So, hi everyone. Michael Boyd, Head of Digital Services within WSP. I look after a digital advisory service within the company, and we provide what would a large proportion of what we do would come under the sort of guise of a BIM consultant. Before that was a dirty word, and an information manager role as a specialist service. Where that's going now is we're finding ourselves managing data for clients. We're becoming the data manager through the process, and ultimately looking at taking that into functional digital twins. So I'm not a structural engineer. I did start off in structural engineering, but where it's coming to now is clients are coming to us saying, look, we're getting a lot of data from the M&E and the architecture, but how can we leverage the data from the structural engineers as well?
Fantastic. Thank you, Michael. Okay, right, I'll stop the share there and we're just going to go into discussion. So hopefully everyone can still see us on live stream. I'm going to start this off with, let's start off easy, shall we? What data, all the stuff we're talking around is fundamentally grounded in data. You know, you've all mentioned it just then immediately. What data is actually useful for us in the engineering industry? Do we know what data we need, and do we have enough of it? Michael, do you want to take that first?
Well, I think it depends on your kind of where you sit, what data. So I represent clients and some of the contractors, and it's not what data, it's the reliability of the data that's really key for them. So something that's come up recently is clients are saying, look, we understand that you're managing the BIM process, that's great. We don't want to see that. The key things we're interested in are visualization of a construction program, so the 4D side of things, but we're also interested in the materials and the volume of materials that are inside of our buildings. And it's all coming to embodied carbon. That's possibly another subject, but they really want to understand and dashboard and benchmark their projects. So whatever data we're producing, they want to be able to see it and they want to understand the reliability of it. So classification, volumes, all that sort of good stuff, but what we put in there has to be correct and validated.
Okay, so you're saying the quality of data is of paramount importance, even over the quantity, is what?
Well, I think the understanding of the reliability, because it's not going to be 100% reliable at day one. But if we understand how much we can rely on it and what we can rely on it for, I think that's more valuable than trying to get it 100% right. Otherwise, people are going to withhold their data.
Okay, that's very interesting. No, thank you. No, John, I mean, you mentioned artificial intelligence and machine learning in your intro, and obviously data is fundamentally the workhorse for that. Do you see that in AECOM that you're sort of the data, there's obviously a maturity stage to kind of get from the start to the end, and I think a lot of companies are going through that at the moment. What do you see are the facilitators to ensure that when we want to implement AI solutions, we have the right data available to us?
Yeah, I mean, it goes back to it's going back to the beginning of the story, really, and it's still about having well, understanding what data you want to capture, mapping that out, and then setting up data standards and conventions, which sounds like the boring piece, and to some extent it is, but that's really what drives the whole thing, because then all your workflows are driven off that common set, and it's not just about structural engineering either. You know, it's about all the other design parameters. And saying as structural engineers, okay, right, we're designing a structure and we're giving it to somebody to build. The actual outcome is a building. And what does the client want from the building? They want to understand the cost. Yeah, material volumes, as Michael was saying, the embodied carbon, the life cycle carbon, all of those things. And you then kind of work backwards from that output and say, well, what do we need as data to inform that? So it can be anything. You know, there's structural engineering analysis data, but there's also what's the project location, you know, what are the site logistic constraints, all of that kind of thing. I could go on, but yeah, it's everything really.
No, that's fantastic. I think, beyond that a little bit, or just to add to that, James, there's the data held within the model, but there's also the metadata associated with files. And now when we're looking at all these vast data sets that we've got, if we had metadata on those files to exactly what John was saying, you know, where it is, the type of project, how it was classified, we would be able to interrogate and benchmark that data much more easier. You know, so if we can standardize that, it would be really valuable.
I mean, that's a great point. So do you think, I suppose bringing this back to the conference itself, do you think the iStruct can support in this regard? You know, the sorts of kind of quality and the frameworks around the sorts of data and the metadata we should be implementing and ensuring is obviously an industry-wide issue, I presume. And therefore, is there somewhere that the iStruct is there something the iStruct can do to help with that process? Emily, I don't know if you want to go with that first.
Yeah, I mean, I think there's definitely some pieces around data standardization and how it's all being collated, so that even if at the moment we don't necessarily know how it interacts in different projects, or like it's built in a way that it can be in the future. And I think the iStruct also have the ability to look a bit wider, to think about the data that we aren't necessarily collecting as default, as maybe if we come from the structural engineering side, how are we collating the more sort of unquantifiables, like what was the constructability like? What was, you know, are we collecting sensor data to try and, you know, actually really understand how it works? And the iStruct has an ability to kind of drive that on a more sort of holistic level rather than an individual structural engineer level or a specific discipline. Okay,
that's a great point. Anyone else want to jump in on anything there? Or is John, you got any thoughts?
I think, yeah, I mean, the sort of a number of the panels on the iStruct kind of have these discussions, and it's yeah, I think what the institution is trying to do is, I suppose, communicate, I suppose, a lowest common denominator almost, and say, well, these are the main things you need to capture. Clearly, the current focus on climate change emergency is driving that, which is great. I think it's making people think a bit more holistically, but also, you know, the actually getting standard data conventions across the board is extremely difficult, and as an industry we might never not get there really. I think people have just got to think of what data do we need within our business. There's always a means of aligning that to another standard. You can always map things, so people shouldn't feel like they're being held back just because there isn't a standard that they can pin everything against now.
No, that's a great point. I mean, I suppose it's a bigger question that's not really touched upon today, but is kind of, you know, we talk about open standards, you know, in like the open standards of the web and stuff like this. So maybe there's kind of a conversation to be had at some point. What are the open standards for our industry, so that we can start to drive that conversation forwards? Okay, I want to move on to a different subtopic. So if we moved, you touched upon there, actually, it's quite nicely led into it, net zero. Where do you think net zero and technology interlink? We've had a couple of good presentations today that have touched on it, from timber and health, you know, monitoring of buildings and health recovery of buildings. So there's clearly a lot of sort of diverse areas in which technology can support and drive the carbon agenda. And what do you personally think, John?
Yeah, I mean, it's comes back to the conversation of data again. I suppose it's been able to inform your decision making fundamentally, and you know, I think the things like the recent iStruct tool is great, again, as a starting point, because you're starting to define a common way of measuring things. But once you start going down these routes, you realise the amount of data on what real embodied carbon factors are is nowhere near where it could be or where it needs to be. So there's a lot of work to do there for sure. And I think, you know, the kind of thing that Emily was touched on in terms of, like, you know, the multi-objective optimization. Again, the structural engineers, we've got to engage with that. You know, we're all developing our own various tools to optimize against carbon. But as you start layering in the other disciplines and you say, okay, light structure equals deep structure equals more facade, even that simple calculation of embodied carbon skews things in a direction you really wouldn't expect. So yeah, I think we've just got to take a lead from the industry point of view.
Okay, that's interesting. No, thank you. I mean, Emily, do you want to come in there? Because he touched quite nicely upon, obviously, optimization problems. And at Ramboll, you mentioned you're obviously quite heavily involved in computational design and parametric modeling side of things. So there must be, well, we know, don't we, from the conversations that have gone on today, that there is a relationship between these sorts of parametric tools and improving our carbon in our designs. Do you want to kind of expand on that a little bit?
Yeah, I mean, it's a very difficult thing. And I think this is where, you know, increases of machine learning, generative design can because the main thing is that often a lot of these things are in contradiction to each other, and, you know, doing something that's good in one place is actually not great in another. And so having the ability to bring in as much data so that you can inform the decision and optimize for it and sort of weight what's most important for that specific project or for that specific client is really an important piece of that. And I think one bit that's maybe missing, or not missing, but is less done, is learning from the performance of existing buildings and existing assets. Because if we really want to, really impact on this carbon thing, we need to be able to design leaner and, really be using data in a way that helps us to do that so that we can really maximize material usage.
Okay, no, that's a great point. Michael, I'd just like to bring you in here. Digital twins. First of all, like from your perspective, where do digital twins? What's the difference between a typical digital twin and just an ordinary BIM model, basic level, just to kind of bring the audience up to speed? And where do you think they fit into this industry, and where do they fit into the net zero agenda?
There's a few questions in there, James. Now, I've changed my mind recently about digital twins. There's a lot of one-upmanship when it comes to, when we talk about digital twins. So my digital twin is more complex than yours. My understanding is more complex. I've changed my mind on that, and I actually like the terminology people are using now to call things a digital twin, because I think it changes the mindset of what they're producing is actually a replica of what will be produced. Now, there's different levels of a digital twin, and I think various organizations have got their own maturity levels, and they all kind of align. But we can have a static digital twin, or we can talk about a dynamic digital twin with two-way sort of interface going between the physical and the digital. Now, generally, when we use the BIM process as a mechanism of capturing data through design and construction that becomes the static data that goes into a client's digital twin. And from there, we start to capture the live data, which is the dynamic data. Now, usually we're only talking about really M&E and a bit of architecture that's feeding into it. I think that's going to change. I think when we're talking about digital twins with structures now, I can imagine certainly bridges and anything there's sort of live loads going over it. I would expect there's going to be sensors in there before long. Because we're talking about using sort of concrete additives that's changing the curing times, I'm expecting to be sensors to be included inside of structures to track that sort of data. So where it fits within the net zero agenda is interesting, because when we talk about digital twins, quite often we're talking about smart buildings. And when we're talking about smart buildings, quite often we're talking about giving people control of their own environment. And sometimes that sort of is in competition with net zero, if you like, because the operational carbon of allowing somebody to change a fan coil unit above their desk, sometimes that's competing. So we need to understand why we're doing it, is where I'm getting with that.
Okay.
So understand the outcome before we produce these sorts of technologies.
No, that's a really, really excellent answer. I suppose that brings me on to a following question, which is, you mentioned about obviously IoT sensors and all these kinds of things coming into these structures, which is undoubtedly the future. I would be surprised if it wasn't. But are we, as an industry, as consultancies, contractors, are we in a position to deal with that volume of data? This sort of real-time data sort of streaming that we'll be getting on a minute-by-minute basis, second-by-second basis, potentially. Can we handle that? And what can we do if we can't? John, what do you think? Do you want to go first?
Oh, I knew you'd ask me that one. Yeah, I mean, look, it's a whole new realm for a structural engineering consultant, I would say, to be dealing with that. It's probably a lot of people consider it to be sat in the bounds of R&D still, but the reality is it won't be for long, and it probably shouldn't be. I think when you're talking about that amount of data as well, you've got to have a very key reason as to why you're capturing it. You need to decide why you're capturing it for a particular structure, what you're going to do with it, and how you're going to share it and analyze it. And just doing that alone, you're setting up separate groups really to do that work, I would say. And,
okay.
So some of the talks today, Thornton Tomasetti one, for example, talking about, most of our big consultancies have their own sort of digital consultancy within the practice. I think that's going to be a model we're going to have to see more and more, because it is becoming more specialist.
Yeah. No, I agree. It's definitely great. Emily, do you want anything to add to that?
Yeah, I think we're in this situation where if we're not careful, there are going to be a lot of tech companies and startup companies that are going to move into the space because they already have the infrastructure in order to, deal with a large bit of data. And so I think maybe COVID has been, in a way, a good way of starting to lay the groundwork. So people being able to think about the digital infrastructure that they have, and companies should be aware that they need to kind of continue building on this to be able to see what's going to be coming in terms of the amount of data that we're going to be able to have and use in the future, and start being ready for it now before someone else gets in there first.
No, that's a great point. I've often thought, you look at the banking industry and how the sort of banks like Monzo and kind of come in and disrupted the whole banking industry, and there's no reason why the same thing couldn't happen to construction, as far as I'm concerned, at some point in the process, So I 100% agree. There's definitely something, we need to make sure we're resilient to that. This obviously, it's been, well, first of all, this has been excellent, and we've gone for ages. I want to touch finally upon education, though, before we move on to the audience Q&A. So for the purpose of students at university now, students younger than university, but also for working professionals that see these kinds of upstarting careers, these exciting work, this exciting kind of work to be involved in, and who at the moment in their current day-to-day work don't get to do any of that. What advice would you give to them to start learning these things? What skills should they be looking to achieve, and what can companies and maybe the iStruct even do to support that? John, I'll start with you, because obviously you're in charge of the digital workflows panel. What do you think about the education side of things?
Yeah, I think, I've probably changed my angle on this over the years as well, because my starting point with this was always focus on being an engineer first, use the tools to be a better engineer. I still believe in that in most cases, but we are seeing more and more specialist coding, mathematic applications where you generally need an out-and-out talent in that field. So I would say, from an education point of view, generally speaking, I think people, if they want to be an engineer and they want to be a creative designer, still focus on the engineering, because most people I see coming out of university just have this aptitude already, and they have this ability already. But there is the alternative career path of more coding, mathematics, which I think, those people ideally will recognize that engineering is an exciting place to get into, but also as businesses, we need to realize that we need to be attracting those people as well.
So you would say then that it's not necessarily existing engineers to sort of change their role, but actually for us to target perhaps computer scientists and data scientists straight out of universities?
Definitely. It's a combination of the two. Yeah.
Okay, that's interesting. That's an interesting view. Michael, any thoughts from yourself?
I think the value of those who understand code their stock has went up massively in the last couple of years, and I think it will only continue to increase. That's the common language between platforms. It's how we get data from A to B, and certainly when we get a CV in and the person understands coding and promotes that, it's always seen positively.
Okay, no, that's fantastic. And Emily, just finally then, if you want to just touch upon that yourself, what's your experience been like coming through Ramboll and moving into this kind of area? Have you found that quite easy to do? Have you been encouraged and supported to do that?
I've definitely been supported, but I can't say that the journey has been without its conflicting between getting chartered through to developing different areas. But I think one thing that I would say as a bit of advice is to understand the value that you add by being someone that branches over both, because that's where you're actually going to get the investment from, is by understanding this is the problem that we're solving for the clients, which you need a little bit of the domain knowledge for, but also a bit of the kind of how can you do it technical knowledge. And so don't underestimate the power of that. And that's something I've personally struggled with understanding, but that would be my advice. And then on the kind of business level, there needs to be work from a project manager or a business level to understand that these kind of digital transformations do require investment at the beginning. And it goes against the sort of traditional workflow that we have as sort of engineers. And so rethinking how that works is, I think, hugely important for businesses to be able to actually create an environment which is conducive to digital transformation.
No,
I think that's where the competitors that Emily was talking about think differently. They tend to sell value and sell their intellect, whereas I think our mechanisms are still set up to sell our time on projects, and that's how we think, and that we need to change that.
Oh, that's fantastic. No, that's been a really, really engaging discussion, actually. You know, definitely for myself, it's been interesting to hear your views. So thank you all. I've got a couple of questions here, just two from the audience. Michael, it's directly to you, this one. With your construction simulation, do you get full contractor engagement to inform the design team at an early stage, or is it all post-tender?
Well, it depends on what type of project and the procurement route we're involved with. Usually we're client side to start off with, and we either remain client side overseeing the contractor, or we're novated to the contractor. Most of the time when we're doing the sort of the construction simulation, the sort of 4D work, we are novated to the contractor and we're performing that with them, with their planners. Now that's kind of morphed a little bit. It used to be we were just linking like a P6 program with the 3D models. Now we're kind of linking that with some of their DFMA process or unitized cladding panels, and making sure the data of, you know, whether the panels are design status A, B, and manufactured, delivered, installed, snagged, you know, and pulling that data in and visualizing that in the program. So that's how that's sort of changing. The earlier, the better, I would say, to get that contractor involvement, but it completely depends on the procurement route that's set up.
Okay, that's excellent. Thank you. To anyone, please, anyone jump in with this. There's been a lot of discussion on capturing real data from actual projects, but do you have any experience in simply generating fictitious data from models, perhaps an ETABS model or a finite model, or to satisfy data demands for deep learning and AI? I mean, it's an interesting concept. Can you just generate data from random iterations of analysis and then use that to feed into an AI model, or does it have to be genuine? Now, I've got my own views on this, but I'm going to let John go first because he seems to, you know, what do you think, John?
I think, yeah, I mean, there's certain applications where you can do that. I mean, something we developed a number of years ago was sort of basic anomaly detection, where you're feeding in geometry models, and it's basically flagging up things which maybe look a bit out of the ordinary. So things like that you can do entirely computationally, and you know, that works pretty well. I think you can do it in other ways as well. But yeah, the combination of computational and real data is really what we want to get to, because that's where we're going to actually learn and move things on.
And I think it's always important with AI to think about what you're actually trying to achieve. Like, if you're trying to produce an idyllic beam design based on idyllic data from an FEA model, then that's fine. But if you want to predict something, you know, in a real life context, but you've generated it from perfect data, then there's a chance your model may not fit the curve. And there needs to be, and so ultimately, like anything, AI models should be validated like general models, you know, so in the same context. And I think that's something worth bearing in mind. I don't know, Emily, Michael, have you got anything to add to that at all?
Yeah, I mean, I think overall I agree with what you said, but I think there's an element of questioning how we're using material a little bit. Like, we obviously built it in a way so that we can build buildings of a certain shape or a certain geometry, because that's, you know, what the environment is now like. And is there a question of, do we need to test that a little bit more in order to build leaner and sensor data, etc., to help really drive that, so that we can not build in our kind of biases from what we've done for hundreds of years.
Okay, that's great. Any thoughts, Michael, or let's touch on the next question?
No, I think that's covered nicely.
Okay, all right. Last question then, before we close off. It's quite philosophical, I guess. When do you think we will reach the holy grail of true multi-directional interoperability between documentation, analysis, and design? And what does that look like? Michael, do you want to go first with that one?
Oh, how dare you? Right, right. I see John smile there. Will we ever get there? The goalposts are always going to be improving. We are getting to the point now. I mean, we're getting to the point where we're standardizing. You know, we're starting to digitize. Soon we'll be automating, and that's when we get into sort of exponential growth. And who the hell knows where we're going to go after that? You know, so that is the sort of step change. I think we need to get the basics right and start to standardize the processes first before we can get to that automation point. But I think the goalposts are always going to change, and I don't think we can foresee that far to actually say when we're going to get there. What it is going to look like. I think we're talking about digital twins here. I think we're talking about an ecosystem of digital twins. If you're if you're interested, have a look at the CDBB sort of digital twins site. There's some fantastic information. But we're talking about an ecosystem of digital twins that all talk to each other. And that's where that common data standards piece comes into it, of how they all talk to each other.
Okay, yeah, so it's interesting. It almost comes full circle back to the concept around kind of open standards, isn't it? Because for true interoperability, you know, the web has achieved it in a way, you know, with standard like web requests and HTTP as protocols that everybody uses, and it doesn't matter what language they're programming in, they can always communicate to another service using an agnostic protocol. So you could argue that it's more a question of if the industry wants to go that way. Do we want a world of full interoperability, or does proprietary kind of commercial gain override that? John, what do you think?
Yeah, I think you nailed it there, really. I think theoretically, if you invest enough, you could get there now. And the reason we don't is because other people, you have your interests. You know, there's always the question of, well, what am I going to do as an engineer? I think generation by generation, people will start to realize we bring our value in different ways, and you can automate much of the structural design piece, like it or not. That's the way things are going to go. But there's also the kind of the conflicting thing of software houses always wanting to do their own USP, so they're not going to align their data standards because they have no interest in doing that. It's maybe controversial, but I think that's true in most cases. And you also have the fact that the people who are doing the clever software development and you know, those really big analysis pieces of software, they're not consultants, so they can't actually take liability as chartered engineers for the design. So there's that kind of disconnect in the industry, even at that level, before you get into construction and supply chains and commercial aspects. I think it's such a hugely complex industry. I don't think we'll get there before I retire, put it that way.
No, there's a lot of moving pieces that all have to align, and it would rely 100% on everybody being motivated to actually achieve that. And until the driver's there, it's not going to happen, I suppose, exactly. Is the answer. Emily, just anything from yourself before we close out?
No, I think you nailed it on the head. You know, IP, the structure of how the industry works, the commercial arrangements that are in place currently are one of the biggest blockers to something like that happening. And until there is that fundamental shift of change of drivers, as you say, it's going to be quite difficult for it to be holistically over the whole industry. But I think there's areas where it can start now. But in terms of full integration, feels like a long way away, at least at the moment. Okay.
Well, I don't know about you, but I've thoroughly enjoyed that session. I mean, I could have carried on that for ages. It's my sort of discussion. I enjoy those sorts of things. But thank you all for your contribution. Michael, John, Emily, you've been fantastic. Thank you again to the audience for your great questions. I'm just going to basically stay on here to do the closing sort of piece. So if the audience can just remain for the last few minutes, I apologize, we've run over very slightly. But again, Michael, John, Emily, thank you very much, and take care.
Thank you.
Thanks.
Okay. So, wow, what an outstanding afternoon it has been. I've personally learned a huge amount from the various presentations and obviously the panel session we've just finished. I'd like to first of all take the opportunity to wish our speakers and our panelists a huge thank you. These events don't happen without you. You bring the content and you bring the great ideas. Further thanks should also be given to yourselves, our wonderful audience, for tuning in, engaging and asking some insightful and thought-provoking questions. Thank you again to our kind sponsors, Antis and BuildSoft. Your support with this event is greatly appreciated, and I hope the audience has had some great opportunities to speak to you during our sessions today. Finally, I'd like to issue a personal thanks to Rachel, Ashley, Michael and Kirsten for their tireless work behind the scenes, making this event a huge success. Without them at the iStructE events team, this event would simply not have happened. So just to summarize today, we've seen a plethora of presentations from both research and industry across a diverse spectrum of specialisms, exploring various contemporary methods and paradigms in structural engineering, ranging from non-prismatic concrete to digital fabrication to optimization to the use of machine learning in design and how these things can relate to our net zero strategy. Our panel discussion, Designing with Data, gave us an intriguing insight into how more digitally oriented practices are already tackling the data opportunities available to us thanks to modern computing. And that brings us to the end of day one. I really hope you've enjoyed the day. Again, please reach out on LinkedIn if you'd like to discuss the topics any further. Reach out to our speakers through the forum, through your attendee hub. I'm sure they'd be happy to hear from you. Day 2 begins tomorrow at 12 p.m. with another hours networking session and exhibition session prior to the esteemed and excellent Catherine Rankin of Arup opening the conference at 1 p.m. and she will be your host for tomorrow and take you through the day's events. I have one final slide to share with you, so let me do that now. Okay, so this is just the program for day 2. That just gives you an idea of what's going to be happening. As I say, 12 o'clock, the official opening is at 1 o'clock with the chair's welcome, Catherine Rankin. I'll stop the share there. And with that, thank you again for joining us. Look forward to seeing you all tomorrow for what is sure to be an equally inspiring session.